Okay, here we are filming the answer key to the practice test for, I think it's actually, what is it, Unit 5 I think it's called. Anyway, it goes up to 3.9 in our new text, so 3.8 is the old text. When looking at this, you're not going to be told if it's implicit differentiation. Of course it is, because the x and y are mixed up. So going through differentiating with respect to x, I got started before my pen died on me here. It's x times the derivative of y squared. So x times the derivative of y squared is 2y. And then it's like mini chain rule. You have to go inside and take the derivative of y, which is y prime, minus the derivative of sine is the cosine. Don't mess with the inside. Then take the derivative of the inside. X times the derivative of y. So that's xy prime, and then y times the derivative of x is that, and equals 0. So now we need to distribute and then to group and simplify. So there's our y prime and here's a y prime, so we get x times 2y y prime minus cosine of xy times xy prime plus, oops, that's a minus, we're distributing a minus cosine in, minus cosine of xy times y. Alright, that's equal to 0. And so I'm going to group these guys right here. I'm going to move that over, factor it out all in one step to save time. 2xy when I tidy this up, and then minus cosine of xy is equal to, put my second parentheses around that, is equal to cosine of xy, and I'm going to put the y out in front. Okay, and then what is y prime equal to? It's just equal to y cosine of xy all over 2xy minus cosine of xy. Okay? Then down here, I've got sort of a chain rule, implicit thing going on, and it's to an exponent. So when you see an unknown in the exponent, it makes a lot of sense to then take the logarithm of both sides. So if I've got ln of xy is equal to, if I take the ln of this, I can bring the y out front. Again, I'm just trying to save time. Y ln of cosine of 10x. Okay? Now we've gotten this into a form that we can take the derivative of and use only the product rule. Makes it a little bit easier. When I take the derivative of this side, it's going to be the derivative of the outside. Don't mess with the inside. Well, the derivative of the ln is 1 over xy. Then times the derivative of the inside, a lot like up here. That's going to be xy prime plus y times the derivative of x is just 1. So just make sure you know your differentiation rules. And then the derivative of this is a product rule, y times the derivative of this, so it's going to be y times 1 over cosine of 10x. Then the derivative of the inside is going to be, I'm going to turn this into, the derivative of cosine is the sine of x. Isn't that clever of me? And then don't mess with that inside, which is 10x. And then finally, times the derivative of the inside, which is 10. I'll put that right there. If I was super clever, I could have snuck it out front. All right. Then that's the first half. This times the derivative of this long thing plus this times the derivative of that. So it's ln cosine of 10x and then times y prime. Okay. Again, I want to find y prime. That's the goal. So what is y prime? Well, I've got a y prime right there, and I've got a y prime right there. So it's group and factor. I've got to distribute each of these in. So this is going to be, and when I do that, I'm saving time. The x's cancel, and I get y prime over y. And then here, the y's cancel, and I'm going to say plus 1 over x is equal to y times, and here's where you can save a little bit of time. It's going to be just that plus, and here, let's see, I'm just going to write it again. Started already. Cosine of 10x, and then, I'll put y prime right there. Okay, so move this over and move this over, and I will get y prime over y minus ln cosine of 10x, and I'm going to actually, y prime, and then that's equal to minus 1 over x plus y times, the parentheses is just this thing there and that thing there. I'm not going to recopy it. Now I'm going to factor out the y prime, which is right there and right there, so it's y prime on the outside, and then 1 over y minus ln cosine of 10x equals 1 over x plus y times that whole mess. So again, our final answer will be y prime is equal to 1 over x plus y times, then it's the sine of 10x, I'll put the 10 out in front, sneak that in, all over cosine of 10x. I suppose you could write tan of 10x because it's sine 10x over cosine 10x. And then this whole thing divided by 1 over y minus ln cosine of 10x. Nobody said calculus had to be beautiful all the time, but there it is. It's using the various implicit and logarithmic techniques right there. Okay. There's no point in multiplying to try to get rid of those fractions. Just leave it as it is in its ugly state. All right. Problem 3. Again, trying to find y prime. This is definitely a candidate for logarithmic differentiation. That is just an ugly alphabet soup of symbols and characters. So I'm going to do ln of y equals ln of that whole thing, which is going to equal, now I'm going to peel it apart. It's something to the 1/10th power, right? So that's going to come out way out front, 1/10. And then it's going to be, when I take the inside bit, these are two things being multiplied. Well, the ln of e is 1, so out in front is going to be that exponent, radical x, okay? And then this is the logarithm of two things that are being multiplied, so that 3 is going to come out in front and be addition, plus 3 ln of 2x, okay? And then it's going to be minus the denominator, which is 1/7, because that's everything to the 1/7 ln of x minus 5. All right. Then we can differentiate this, all right, because it's all spread out. So it's going to be 1 over y prime is equal to, and then that 1/10 stays out front. That's just a constant. Inside here, that's something plus something minus something. So the derivative of radical x to the 1/2 is 1/2, then square root of x. You've done that before. Plus, when I take the derivative of this, it's going to be 3 over 2x, and then the derivative of 2x is times 2. I love it when I lose the power. Got back. And then it's going to be minus 1/7 times x minus 5, and then the derivative of that is just 1. So it's going to be that, and then times, and then I said please write the complete answer. This whole thing times e to the radical x times 2x to the 3rd all over the 7th root of x minus 5, and then you can write to the 1/10. Okay? So again, another kind of less than beautiful solution, but nevertheless there it is. Okay? Finally, on to number 4, before we have to probably switch gears. We've got inverse sine and inverse cosine of x. And to take the derivative of this, then y prime, it's just going to be a chain rule. What's the derivative of the inverse sine? Hopefully you remember it's 1 over the square root of 1 minus x squared. And then I've got to take the derivative of the inside and put that in there. So this bit here goes right in for that. So I should be more careful, but it's 1 over the square root of 1 minus cosine to the minus 1 of x squared, and then times the derivative of the inside. The derivative of cosine, inverse cosine, then is 1 over the square root of, that's a minus, 1 minus, and then x squared. So the big difference between the inverse sine derivative and the inverse cosine derivative is just that minus sign there. Okay, so I would leave it like that. Okay, and call it a day. Good job. Moving on to the next page next.